Iterative algorithm index increasing. So this is the formula. Let bits equals bit representations number the vector of bits from LSB to MSB representing S. Let res equals 0 number point at infinity. Let temp equals p number track doubled p val. For bits in bits, if bits equals 1, res equals res plus temp number point add. Temp equals temp plus temp number doubled. Then return to res. So the process of attempting for solving a problem which find successive approximation for solution is starting from an initial guess. The result of repeated calculation is sequence of approximate values for the quantities of interest. Iterative algorithm index decreasing. So here is the formula. Let bits equals bit representation number the vector of bits from LSB to MSB representing S. Let I equals length times 2 bits minus 2. Let res equals p, while I is greater than and equal to 0. Number traversing from second MSB to LSB. Res equals res plus res number double. If bits I is equal and equal to 1, res equals res plus p and number add. Then I is equals to I negative 1. So here, every decreasing sequence of natural numbers is finite. Encryption rules. Suppose we let A equal 2 and 7 and choose the private key to be 7. Then B equals 7A equals 7 and 2. Encryption. So here is the formula where X element of E and 0 is less than and equal to K and less than and equal to 12. So here, encryption involves converting human-readable plain text into incomprehensible text, which is known as ciphertext. Especially, this means taking readable data and changing it so that it appears random. Encryption involves using a cryptographic key, a set of mathematical values both the sender and recipient agree on. Decryption rule. Decryption. So here is the formula of decryption. This is based on the El-Gamal scheme of elliptic curve encryption. So the conversion of encrypted data into its original form is called decryption. It is generally a reverse process of encryption. It decodes the encrypted information so that an authorized user can only decrypt the data because decryption requires a secret key or password. Encoding of a message onto the elliptic curve. Consider a curve y2 is equals x, 3 plus ax plus b. The plain text are say numbers and English character 0 minus 9 and 10 minus 35. B is encoded as m equals 11. Choose a public variable k is equals to 20. Compute x equals mk plus I. Vary I from 1 to k minus 1 and try to get an integral value of y. Thus, m is encoded as x and y. The decoding is simple. M equals floor x minus 1 divide to k. 23 minus 27 May 2011. 2327 May 2011. Anurag Labs DRDO 10. Encoding of a message onto the elliptic curve. So here is the example of encoding of a message onto the elliptic curve. Elliptic curve cryptosystem analog to LGAM. So the example is Alice chooses another random integer k from the interval 1p minus 1. The ciphertext is a pair of points. PC is equals to K and B, PM plus K and PB. To decrypt Bob computer, the product of the first point PC and his private key B and B times K and B. Bob then takes this product and subtracts it from the second point from PC, PM plus K, PB minus B, K and B equals PM plus K, PB minus B and K and B equals PM. Bob then decodes PM to get the message M. 23 minus 27 May 2011. Anurag Labs DRDO 12. The implementation of elliptic curve cryptography requires several choices, like the type of finite field algorithm for implementing the elliptic group operation and elliptic curve protocols, which influence the performance of ECC. Defining the identity. The point at infinity 0 is the identity element. P plus 0 is equals to 0 plus P is equals to P for all P element of E. From case 2 and the identity element, we now have the existence of inverses. Beyond the scope, here to prove that we have commutativity and associativity as well. Therefore, the set of solution E forms an abelian group. Importance of this will be shown later.
Defining the identity. The point at infinity 0 is the identity element. P plus 0 equals 0 plus P is equals to P, for all P is an element of E. From case 2 and the identity element, we now have the existence of inverses. Beyond the scope, here to prove that we have commutativity and associativity as well. Therefore, the set of solutions E forms an abelian group. Important of this will be shown later. Elliptic curves modulo P. Let P greater than 3B prime. The elliptic curve y to the second power equals x to the third power plus ax plus b over zp is the sets of solution x and y is an element of zp times zp to the congruence, where a is an element of zp and b is an element of zp, are constant such that 4a to the third power plus 27b to the together with the special point 0 called the point infinity. Solution is still form an abelian group. So now, for an example, let's examine the following elliptic curve as an examples. Y to the second equals x to the third power plus x plus 6 over z, 1, 1. So, as you can see, x is equals 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X to the third plus x plus 6, mode 11 is, we have 6, 8, 5, 3, 8, 4, 8, 4, 9, 7, 4. What is the QR? So, we have n N, Y, Y, N, Y, N, Y, Y, N, Y. And the elements of Y is, in 2 we have 4, 7, in 3 we have 5, 6, and in number 5 is 2, 9, in number 7 is 2, 9 also, in number 8 is 3, 8, and the number 10 is 2, 9. Generating our group. From the previous chart and including the point infinity 0, we have a group with 13 points. Since the O, E is prime, the group is cyclic. We can generate the group by choosing any point other than the point at infinity. Let our generator equals A equals 2 and 7. The group. We can generate this by using the rules of addition we defined earlier, where 2a is equals a plus a is equals to 7, 4a is equals to 10, 7a is equals 7 to 10a is equals 8, 8. 2a is equals 5, 2, and 5a is equals 3, 6, and 8a is equals 3, 5, and 11a is equals 5, 9. We have 3a is equals to 8, 3, 6a is equals to 7, 9, 9a is equals 10, 9, and 12a is equals to 4. Using this scheme, suppose Alice wants to send a message to Bob. Plain text is x is equals 10, 9, which is a point in E. Choose a random value for k. K is equals to t. So now calculate 1, y1, and y2. y1 is equals 3, 2, and 7 equals 8 and 3. Y2 is equals 10, 9 plus 3, 7, 2 equals 10, 9 plus 3, 5 is equals to 10, 2. Alice transmits y is equals to 8, 3 and 10, 2. Bob decrypts. Bob receives y is equals to 8, 3 and 10, 2. Calculates. X is equals to 10, 2 minus 7, 8, 3 equals 10, 2 minus 3 and 5 equals 10, 2 plus 3, 6, which has the plain text. So we have 10, 9. So here the real example from the NSA.